If you tried to land on Jupiter, you wouldn't hit the ground. You wouldn't even know when you cross the point of no return, because on Jupiter, there is no surface to arrive at. By the time this video ends, you'll understand why Jupiter isn't just the largest planet in our solar system, it's the most alien, and why it may have played a larger role in making Earth possible than anything else in the sky. Imagine falling, not toward land, not toward water, just down, into clouds that don't end. At first, it doesn't feel impossible. You're drifting through the upper atmosphere of Jupiter, a place colder than Antarctica, around -140 degrees Celsius. The clouds around you are made of ammonia ice and chemical vapors. It's alien, but not immediately deadly. This is the part most people imagine, but it's also the least dangerous part of Jupiter, because the real problem isn't where you are, it's what's coming next. The deeper you fall, the thicker the atmosphere becomes. On Earth, you fall through air and hit the ground. Here, there is no ground. The gas just keeps compressing, denser, heavier, more resistant. The hydrogen around you stops behaving like a normal gas. It begins to act like a fluid. There's no boundary, no clear transition, just a slow, continuous increase in pressure. And pressure is what kills you first. Within minutes, the force around you rises beyond anything your body is built to withstand. It's not an explosion, it's a steady, crushing squeeze from every direction at once. You don't get a moment of impact, you just stop being able to exist in one piece. But let's say you were somehow protected, something strong enough to survive the pressure. You keep falling. Now, the planet starts to reveal what it really is. Jupiter isn't just a big ball of gas. It's a system powered from within. Even today, it radiates more heat into space than it receives from the sun. That energy comes from slow gravitational contraction, Jupiter very gradually shrinking under its own gravity, converting that collapse into heat. And that heat drives everything around you, the storms, the turbulence, the violence of the atmosphere, including the most famous one. If your descent takes you near the Great Red Spot, you're not entering a storm like on Earth. You're entering a system larger than entire planets, a vortex that has been active for centuries. Wind speeds exceed 400 kilometers per hour. The storm doesn't weaken because there's no solid surface to slow it down. No land, no friction, just energy, feeding energy. You wouldn't pass through it, you would be torn apart, long before you understood its scale. But before we go any deeper, we need to understand what Jupiter actually is at the scale of the solar system. Because the descent you're on right now is happening inside something almost incomprehensible in size. Around 1,300 Earths could fit inside Jupiter. It contains more than twice the mass of all the other planets in the solar system combined. Its gravity doesn't just hold its moons, it shapes the entire system. In fact, Jupiter and the Sun don't orbit in a simple way. They both orbit a shared center of mass, and that point actually lies just outside the Sun's surface. Jupiter is that significant. Early in the solar system's history, Jupiter likely didn't stay where it is now. Evidence suggests it migrated inward before moving back out to its current orbit. During that time, it would have disrupted enormous amounts of material: asteroids, debris, early planetary building blocks. That movement may have influenced why Mars is so small. It may have affected how Earth formed. But it's not a simple story of protection. Jupiter can deflect objects away from the inner solar system, but it can also redirect them inward. It is both a shield and a trigger, and we've seen exactly what happens when something gets too close to that gravity. In 1994, comet Shoemaker-Levy 9 broke apart under Jupiter's gravity and slammed into the planet over 6 days. The impacts tore open the atmosphere, leaving dark scars, some nearly as wide as Earth itself, visible from backyard telescopes across the world. Jupiter absorbs impacts like this, but the same gravity that captures objects can also send them elsewhere. The difference is direction. Now, back to where you were, still falling. The deeper you go, the hotter it gets. This is the opposite of Earth. You're moving away from sunlight, but the temperature keeps rising, hundreds of degrees, then thousands. The pressure has now reached millions of atmospheres, conditions that simply don't exist anywhere naturally on Earth's surface. At these extremes, hydrogen, the simplest element in the universe, starts to change. Not chemically, physically. The atoms are forced so close together that their electrons begin to move freely between them, the same way electrons flow through a copper wire, giving it the ability to conduct electricity. Except here, that conductive material isn't a wire, it's an ocean. The hydrogen becomes electrically conductive. You are no longer falling through gas. You are falling into an ocean of liquid metallic hydrogen. And we haven't even reached the strangest part yet. There is no surface here, no horizon, no up or down that makes sense anymore. Everything around you is dense, reflective, and electrically active. This layer makes up most of the planet's interior. And it's moving. Jupiter rotates once every 10 hours. That rotation, combined with this vast ocean of conductive fluid, generates something enormous. A magnetic field so powerful that it reshapes space around the planet. Now here's the part that would have killed you long before the pressure did. Jupiter's magnetic field traps charged particles, mostly electrons, and accelerates them to extreme energies. These particles spiral along magnetic field lines, forming radiation belts that make Earth's Van Allen belts look like background noise. Near Jupiter's innermost moons, radiation levels are high enough to flood unshielded electronics with lethal doses within hours. For a human being, the exposure at that distance would be fatal in minutes. You wouldn't need to fall into Jupiter to die. You wouldn't even need to touch it. Spacecraft sent there have to be specially shielded just to survive long enough to send data back. Jupiter doesn't just crush you. It surrounds itself with a region that prevents you from ever getting close, safely. Now go back to where you were, falling, because even deeper inside Jupiter, things become less certain. Data from NASA's Juno spacecraft, which has been orbiting Jupiter since 2016, suggests that Jupiter may not have a well-defined solid core. Instead, heavy elements, rock and metal, are likely spread out, mixed into the surrounding layers. A fuzzy core, not a center you could reach, just a gradual transition into something denser, hotter, and harder to define. Temperatures here may reach around 24,000 Kelvin, hotter than the surface of the sun. At these conditions, the rules of everyday chemistry stop applying in any familiar way. This is not a place built for matter, like you. But what if the question isn't destruction? What if it's existence? What if you never went that deep? What if you stayed higher up, in the upper atmosphere, where pressures are lower, temperatures are less extreme, and chemistry is active? Could anything exist there? Scientists like Carl Sagan once considered that possibility. Not life like plants or animals, but floating organisms, structures that could maintain buoyancy in the atmosphere, drifting through layers of gas, feeding on chemical gradients. They would never touch a surface, because there isn't one. They would live entirely within motion, rising, sinking, carried by currents in a world where ground is meaningless. No such life has been confirmed, but the idea remains open. And that leaves you with a final perspective. Jupiter isn't terrifying because it has storms, or because it's big, or because it lacks a surface. It's terrifying because it removes the assumptions you rely on to understand a planet. There is no place to stand, no clear boundary, no stable reference point. Only increasing pressure, increasing heat, increasing uncertainty. You don't arrive on Jupiter, you just go deeper, until the idea of you stops making sense. And the only reason you're not experiencing that right now is because you're very, very far away from it. If you had to choose, where would you stop on the way down? The upper clouds before the pressure builds? The edge of the Great Red Spot? Or would you dare to go all the way to the ocean of liquid metal? Tell me in the comments. I want to know exactly how deep you'd go. And if this felt more like an experience than a lesson, subscribe. There's a lot more of the universe that makes just as little sense as Jupiter. We're not done yet.